Dear students, hope all of you are fine and enjoying your vacation. Stay safe, stay calm, and stay tuned here now. You have already studied about the chapter electricity, and we have covered some of the topics like electric current, potential difference, resistance, Ohm's law, like that. So here we will first revisit whatever we studied, and then we will proceed to discuss a certain new concepts. So let's recall what is electric current. As we all know, it is the flow of electrons through a conductor. Suppose if you have a wire or just hold the wire and leave it on a table, then we can see that the current will not flow through this wire, because we know that current is only flowing through a wire in a way when connected to a source of charge or source of electrons. This source of electrons or source of charge will provide the necessary energy for the electrons to flow. So the device which causes the flow of electrons through a conductor is called, we call it as a cell. And as we all know, a cell has a positive terminal and a negative terminal. The combination of cell is called what? The combination of cell is called a battery. Okay, as we all know that electrons are the negatively charged particles, and they always flows from negative terminal to the positive terminal of the battery or a cell. At the same time, electric current flows from the positive terminal to the negative terminal of the cell or battery, and this current is also called conventional current. So let's recall that. We know that it is electric current is the flow of electrons through a conductor, and the device which provides the source of electrons is called it as a cell or a battery. If we consider electric current, we need to discuss about expression for electric current. To find out the expression, we have to take another definition for electric current. That is, electric current is taken as the rate of flow of electric charges through a conductor. It is the rate of flow of charges through a conductor. Or it is taken as the quantity of charges flowing through a conductor per unit time. Quantity of charges flowing through a conductor. Quantity means the amount of charges flowing through a conductor in a per unit time. It is also, we can discuss that electric current is taken as the quantity or amount of charges flowing through a conductor per unit time. So this definition will give a formula for current, that is, electric current equals amount or quantity of charge divided by the time taken. Then for electric current we are putting the letter I, and for electric charge we are putting the letter Q, and for time T then we have the formula I is equal to Q divided by T. I is equal to Q divided by T. So the formula for electric current is I is equal to Q divided by T. And also we studied that the SI unit of electric charge is taken as coulomb, and it is the charge contained in 6 × 10⁻⁸ electrons, the number of electrons in 1 coulomb of charge. As we already studied that the number of charges in 1 coulomb charge is 6 × 10⁻18 number of electrons, that is 6 × 10⁻18 electrons. So next we have to discuss about the unit and instrument used for electric current. The SI unit of current, from the definition we are getting the SI unit of current. The unit of current we can take as the coulomb per second. This coulomb per second is also called ampere. So the SI unit of current is taken to be ampere. So 1 ampere is equal to 1 coulomb divided by 1 second. So SI unit of electric current is called ampere. 1 ampere equals 1 coulomb divided by 1 second. And we have to discuss, or we have to define, what is 1 ampere. It's the most important question and frequently asked one. So how do we define 1 ampere? We know that 1 ampere is equal to 1 coulomb divided by 1 second. This 1 ampere is the current flowing through a conductor if 1 coulomb of charge flows through it in 1 second. So once more, 1 ampere is the current flowing through a conductor if 1 coulomb of charge flows through it in 1 second. That is, 1 ampere is equal to 1 coulomb divided by 1 second. Okay, so electric current is measured by using an instrument or using a device which we call it as an ammeter. So ammeter is the device or instrument used for measuring electric current. It is always connected in series in a circuit. An ammeter is always connected with a circuit. It is always connected in series in a circuit because then only we can measure all the currents flowing through that circuit. So we just recall about electric current, its definition, its equation, SI unit and instrument. Okay. So let's discuss about the term electric circuit. We always saying the term electric circuit in all the time. In this chapter, electric current or electricity. So when we consider an electric circuit, it is considered to be a continuous path in which electrons from a voltage or current source will flow. An electric circuit is a path in which electrons from a voltage or current source will flow. That is, in short, we can define that it is a continuous and closed path of an electric current. So, electric circuit can be defined as a continuous and a closed path. It should be continuous and it should be closed. It is a continuous and closed path of an electric current. So, once more, electric circuit is considered to be a continuous and closed path of an electric current. An electric circuit is of two types, open circuit and closed circuit. So an electric circuit is of two types, open and closed circuit. So students, please understand the picture given here. If the wire in the picture has broken anywhere, that is, if the switch is open stage or the switch is in off stage, then there will be no current flow, and then such a circuit is called open circuit. That is, in an open circuit, there will be no current flow. Then current will only flow when you have provided a continuous and a closed path. So we can understand that current will only flow when you have provided a continuous and closed path. For that, the switch must be in on stage. So if the switch is in on stage, there will be a current flow. Then that kind of circuit is called a closed circuit. So current will only flow when the switch is closed or switch is in on stage. Then such a circuit is called a closed circuit. So an electric current is a continuous and a closed path of an electric current. Electric circuit is considered to be two kinds, open circuit and closed circuit. Through an open circuit, no current will flow. Through a closed circuit, there is a current flow. We know that a cell or a battery act as a source of electrons or act as a source of an electric current, which is making electric current flow. So then we need to discuss about electric potential and the electric potential difference, which is created at the ends of a wire or at the ends of a circuit by means of the cell or battery. So next we go through the topic which is called the electric potential and potential difference. So electric potential is considered to be the capability of a charge to move a unit positive charge from one point to another point. Electric potential is the capability of a charge to move a unit positive charge from one point to another point. When we consider electric potential difference, it is the work done in bringing a unit positive charge from one point to another. When we consider an electric potential difference, it is a work done in bringing a unit positive charge from one point to another point. If you write its formula, then we can write that electric potential V is equal to work done divided by the charge Q. So electric potential V is equal to work done divided by charge Q. That is V is equal to W by Q. So the SI unit, from this formula we can find out the unit for electric potential, and it is found that the unit of electric potential is joule per coulomb. It is also called a volt. So the SI unit of electric potential and also the electric potential difference is volt. Its symbol is also capital V. And we know that it is the potential difference is measured by using a device called the voltmeter. As we studied earlier that electric current is measured by using a device called ammeter. Here electric potential is measured by using a device called voltmeter, and the voltmeter is always connected in parallel in a circuit. Voltmeter is always connected in parallel. Remember that ammeter is always connected in series in a circuit. Once again, look here. Here we have two figures, figure 1 and figure 2. The figure 1 explains what is an electric potential. In figure 1, a charge is moving from infinity to a point A. So here electric potential is the work done in moving the charge Q from infinity to a point capital A. So Work done in moving a charge, unit charge from infinity to a particular point is called the electric potential. So in the second figure, we can see there are two positions A and B, and the same charge is moving from infinity to the point A and also infinity to the point B. So we have two potential at A and B. The difference between the potential, the difference in potential at these 2 points can be taken as the potential difference. So there should be 2 points and 2 potential at the points A and B. So the difference in potential at these 2 points can be taken as the electric potential difference, and its formula is potential difference V is equal to W by Q. So we can discuss about why is potential difference important. That is, electric current will flow through a conductor if there is a difference in electric potential between the two ends of the conductor or the metallic wire. That we studied that electric current will only flow through a conductor or a wire whenever there is a difference between the potential at the two ends of that wire or conductor. If you have a wire and not connected to a cell or a battery, suppose if you have a wire and not connected to a cell or a battery, then both the ends have same potential. If the potential difference or if the potential at these both ends, if the potential difference or if the potential at the both ends are same, then we can see that the charge will not flow. The charge will not flow and there will be no flow of current through it. Once more, if you consider a wire and not connected to a cell or battery, that means both the ends have same potential, then there will be no current flow. That means there will be no flow of charges through it. If you want an electric current flow, then we must provide an electric potential difference. So for that, we should connect this metallic wire, this conductor, to a cell or battery. So we can see that electric potential difference is provided by a cell or a battery. So with this, we have the expression for potential difference, that is potential difference V is equal to W by Q. And the SI unit of potential difference is also volt, and 1 volt is equal to 1 joule per 1 coulomb. 1 joule per 1 coulomb. Here also we have to define what is 1 volt. So how will you define 1 volt? That is 1 volt equals 1 joule per 1 coulomb. This 1 volt is the potential difference when 1 joule of work is done to move a charge from one point to another point. 1 volt is the potential difference when 1 joule of work is done to move a point or to move a charge from one point to another point. Then we can see that, and we also say that electric potential is measured by using a device called voltmeter. Here also potential difference is measured by using the same device called voltmeter. When we are measuring potential difference, that is actually measuring the potential between the 2 points. When we are measuring potential difference or actually measuring that is potential difference means the potential between 2 points. That is why it is connected in parallel across the 2 points where potential difference is to be measured. So a voltmeter is always connected in parallel across the 2 points of a metallic wire. So the relation between this electric current and the potential difference is provided by a law which is called Ohm's law. So next we have to discuss about what is Ohm's law and the related terms. So the relation between electric current and potential difference is given by or provided by a law named Ohm's law. Let us discuss about Ohm's law. When we consider Ohm's law, it states that the current flowing through a conductor or a metallic wire is directly proportional to the potential difference between its two ends, provided all the physical conditions remains the same. Here the physical conditions means the temperature, pressure, etc. So according to Ohm's law, the current flowing through a conductor or a metallic wire is directly proportional to its potential difference between its two ends, provided temperature remains the same or temperature remains constant. That means if you increase the applied potential difference, the current will also increases. If you decrease the applied potential difference, the current will also decreases. That is why we state that current is directly proportional to potential difference. So once more we can state Ohm's law. That is, Ohm's law states that the electric current flowing through a conductor or metallic wire is directly proportional to the potential difference between its two ends, provided temperature remains constant. So from Ohm's law, we are getting the relation that electric current I is directly proportional to potential difference V. That is, I directly proportional to V. Now we can see the circuit diagram for Ohm's law. See that circuit diagram given here. In that circuit diagram, there is a voltmeter. It is connected across the resistance wire, and there is an ammeter, there is a switch and a battery. We know that battery or cell provide the necessary potential difference. The ammeter is used for measuring the electric current flowing through the circuit, and voltmeter is used for measuring the potential difference developed in the circuit. Then by using this circuit diagram, we can make the connections. We can make the connections and take the readings. And take the readings from both voltmeter and ammeter. And by using these readings, we can plot a graph. We can plot a graph by taking potential difference along y-axis and current along x-axis. Then we can see that the graph given is a straight line which is upward showing. So the graph between the potential difference and electric current by using Ohm's law is a straight line graph. So this straight line graph shows that electric current I is directly proportional to potential difference V, or V is directly proportional to I. To remove the proportionality symbol, we put a constant, that is capital R. So the formula will be V is equal to IR. So the equation for Ohm's law is V is equal to IR. Equation for Ohm's law is V is equal to IR. So this is the famous Ohm's law equation, V equals IR. Here R is a proportionality constant which is known as resistance of the given metallic wire at that temperature. R is a proportionality constant known as resistance of the given metallic wire or the conductor at that temperature. So we can once more concluding the Ohm's law. According to Ohm's law, electric current flowing through a conductor is directly proportional to the potential difference between its ends, provided the temperature remains constant. So Ohm's law equation is V is equal to IR, and R is a constant called resistance of the given metallic wire or conductor. Now resistance is defined as the obstruction to the flow of current. It is the opposition, or it is the obstruction to the flow of electric current. It also taken as R is equal to V by I. That is, resistance is taken as the ratio of potential difference to the electric current. Resistance is taken as the ratio of potential difference to the electric current. That is the equation for resistance is R is equal to V by I. R equals V by I. So from Ohm's law equation, we are getting an equation for resistance R, that is R is equal to V by I. From this equation, we can find out the unit. So the unit for resistance is volt per ampere. This volt per ampere is also called the ohm. So the SI unit of electrical resistance is said to be ohm. Next we have to define 1 ohm. So for defining 1 ohm, we have to find out the equation. That is from Ohm's law, V is equal to IR, then R is equal to V divided by I. The unit for R is ohm, unit for V is volt, and unit for I is ampere. That is 1 ohm is equal to 1 volt divided by 1 ampere. So we can define 1 ohm from this equation. 1 ohm equals 1 volt divided by 1 ampere. If the potential difference across two ends of a wire, given metallic wire, is 1 volt and the current flowing through it is 1 ampere, If potential difference is 1 volt and current flowing through it is 1 ampere, then resistance of the given conductor is said to be 1 ohm. So once more we can define 1 ohm. If the potential difference across two ends of the conductor is 1 volt and the current flowing through it is 1 ampere, then the resistance of the conductor is said to be 1 ohm. So 1 ohm equals 1 volt divided by 1 ampere. From the equation Ohm's law, V is equal to IR or I is equal to V by R. That is, I is inversely proportional to R. I proportional to 1 by R. I is inversely proportional to R. I means the electric current, that is, electric current is inversely proportional to resistance of the given wire R. Both are inversely proportional. That means that if resistance increases, the current will decreases. Again, if resistance decreases, the current will increases. So both electric current and resistance are inversely proportional to R. That is why we define resistance as the property of a conductor to resist the flow of electric current. Resistance is defined as the property of a conductor to resist the flow of electric current through it. If resistance is doubled, then current gets halved. If resistance is doubled, the current gets halved. Again, if resistance is halved, the current gets doubled. So we discuss about electric current, electric potential difference, Ohm's law, and also the resistance. So dear students, hope all of you are listening this session and makes the topics clear. Thank you.